10 real data scientist interview questions from a Quest2Offer mock. Pause on each one, think how you'd answer, then I'll show you how. Let's go. Walk me through the bias-variance trade-off. It's the split between error from a model too simple and error from a model too sensitive. High bias underfits. It misses the pattern. High variance overfits. It learns the noise. As you add complexity, bias drops while variance climbs, so you tune for the sweet spot that minimizes total error on unseen data, not the lowest training error. How do you detect and prevent overfitting? You spot it when training scores are high but validation scores lag. A widening gap is the tell. Prevent it with more data, regularization, simpler models, dropout, and early stopping. Cross-validation gives you an honest estimate, so one lucky split doesn't fool you. The core move is always judging on data the model never saw. Precision versus recall. When do you optimize for each? Precision is how many of your positive predictions are correct. Recall is how many actual positives you caught. Favor precision when false positives are costly. Flagging a good transaction as fraud annoys customers. Favor recall when misses are costly. Cancer screening, where missing a sick patient is far worse than a false alarm. F1 balances both when you need one number. How do you handle a heavily imbalanced dataset? First, stop trusting accuracy. Use precision recall and PRAUC, which is far more honest than ROC AUC under heavy imbalance. Then rebalance. Oversample the minority with SMOTE, undersample the majority, or apply class weights so rare case errors cost more. Sometimes reframing it as anomaly detection works better. Whatever you do, evaluate on the real untouched distribution, never on resampled test data. Explain a p-value to me in plain language. A p-value is the probability of seeing a result at least this extreme if the null hypothesis were true. Basically, if nothing real were going on. A small p-value, under 0.05 by convention, means the data would be surprising under no effect, so we doubt the null. It's not the probability your hypothesis is true, and it says nothing about effect size. Quick pause. These are real questions from Quest2Offer's AI mock interview. Pick your target role and level, answer out loud or in writing, and get a breakdown of exactly where you'd get cut. It's free to try at Quest2Offer.ai. Now, back to the questions. How would you design an A/B test and what trips people up? Start with one clear hypothesis and a primary metric, then compute your needed sample size before launching. Randomize properly and run for full business cycles to absorb weekly seasonality. The classic pitfalls: peaking and stopping early, which inflates false positives, ignoring novelty effects, and testing so many metrics that something looks significant by chance. What's the difference between L1 and L2 regularization? L1 or lasso penalizes the absolute value of weights and can drive some exactly to zero, so it doubles as feature selection and yields sparse models. L2 or ridge penalizes squared weights, shrinking them towards zero but rarely to it, which handles correlated features gracefully. Use L1 for a sparse, interpretable model, L2 for stable shrinkage. Elastic Net blends both. How do you handle missing data? First, understand why it's missing. Completely at random is safe to drop or simple impute. At random is recoverable with model-based imputation on the observed data, and not at random can bias everything. For small gaps, mean, median, or model-based imputation works. For richer signal, add a "was missing" indicator flag. Avoid dropping rows unless the loss is trivial. And always impute using training set statistics only. Fit inside cross-validation so you don't leak. Explain k-fold cross-validation and why it matters. Split the data into k-folds, train on k-1 and validate on the held-out fold, then rotate until each fold has been the validation set once. Average the scores for a stable estimate that doesn't hinge on one lucky split. Use stratified folds for imbalanced classes and time series splits when order matters, so you never train on the future. How do you explain a model to non-technical stakeholders? Lead with the business outcome, not the algorithm. This flags the 5% of accounts most likely to churn. Then show which factors drive predictions using feature importance or SHAP, which attributes each prediction to its inputs. Use plain analogies, one concrete example, and honesty about confidence and limits. They need to trust and act on it, not understand the math. That's all 10. How many did you get? Tell me in the comments, and like, subscribe, and try a real mock interview at Quest2Offer.ai. Good luck out there.